Hello everyone, today we're going to be talking about electric potential and the human body and what exactly is electric potential, the fact that the human body is a very good ideal conductor for electricity, and trying to understand just how we see physics in our everyday lives, especially in the medical field. So a really good example of this is, first of all, to talk about what electric potential is. And so basically, electric potential can be defined with a simple equation. So delta V is equal to delta U over Q sub O. And the best way of looking at it is electric potential energy per charge. So that's basically how it's best seen. Q sub O, as we know, is test charge. Okay? This delta U is basically electric potential energy. Okay, and of course, as we know, this one is the electric potential. Alrighty, so what is an ideal conductor and how is it seen in our bodies, and why is our body a really good conductor of electricity? Well, one of the main reasons the body is an ideal conductor, especially good for conducting electricity, is muscle activity, the beating of the heart, muscle contraction, nerve impulses in the brain. And there are also different ways of measuring these things. And one of the best ways is basically with an electrocardiograph. An electrocardiograph is known as an ECG or an EKG. Okay? So I'll leave this here for you. So one of the best ways of measuring it, like I said, is an EKG, also known as an ECG, which is an electrocardiogram. Okay? And basically things like muscle activity, the beating of the heart, and the nerve impulses in the brain, basically all of these lead to small changes in the electric potential. So with the electrocardiogram, you're basically looking at the heart muscle contraction, and you're also looking at basically your heart rhythm and things like that. So the electrocardiograph is how the electrocardiogram is used with. Okay, that's the main instrument. And this is how basically you start to see how physics really is related into our day-to-day lives, especially, like I said, in the medical field. And so with the EKG or ECG, you can basically look at the heart rhythms, again with the electrocardiogram, and the best way of looking at it is with this drawing right here. This is basically how they look at it. Okay, so we have the P wave right here, we have the Q wave here, the R, the S, and the T. This is known as something called the QRS complex, and it's pretty much the very beginning of the pumping action of the heart, so it's extremely, extremely important. The P wave right here is known as atrial depolarization. Okay, the R right here at the very top is at the peak. It's known for ventricular depolarization. Okay, and of course the T wave. The T wave is known for ventricular repolarization. So another way of looking at the two words repolarization and depolarization, obviously ventricular repolarization is at the T. So basically it's repolarizing, or in other words recharging itself. And after this whole process is done, it does it all over again. So that's basically how the electrocardiogram is seen. and how the electrocardiograph is used, of course. And so the word depolarization can occur in all 4 chambers of the heart. And for me, it's easier to look at the 4 chambers of the heart by actually drawing it out. So I like to draw out the heart to kind of see the 4 ventricles of the heart, just to better understand how exactly the electrocardiogram is seen or read. So basically you have the right atrium, you have the right ventricle over here at the bottom, the left ventricle, and the left atrium. And depolarization is seen in all 4 of these chambers. And depolarization basically is when the SA node sends depolarization waves to the AV node, I believe as known as the atrioventricular node. And it causes contraction in both of the 2 ventricles that are right here at the bottom. Okay, the repolarization part is a change in membrane potential that returns membrane back to a negative value. So when it's at this T wave here, it's returning it back to a negative value. And that's why the whole thing just starts all over again, and that's how the heart muscle contracts. Okay, another really good way of trying to see why the human body is a really good form of, or at least a really good ideal conductor of electricity, is something called an EEG, an electroencephalogram. And basically you're basically looking at the nerve impulses in the brain. So a good way of looking at it is with the electric encephalogram is the EEG, okay? Electric encephalogram. Okay, and it is shown in waves. That's its main function here. Well, of course, its main function is to detect the, it's basically used to detect the nerve impulses, or, the nerve impulses in the brain. And like I said, it's shown in waves, and there are several different kinds of waves called the D waves, the A waves, the B waves, and the Q waves. Okay? The D waves are mainly seen in sleep. Okay? Your A waves are usually seen in just a relaxed brain. And they can range anywhere from 8 to 13 hertz. Okay, that's normal for them. The B waves are mainly seen in a very alert brain. And they're seen anywhere from anything over 13 hertz. Okay? And your Q waves are mainly seen in newborn babies, but if you see anything greater than 5 to 8 hertz, or actually anything greater than 8 hertz in a Q wave, usually that's considered stress in adults, but it's normally seen in newborns. Like I said, in anywhere near 5 to 8 hertz. That's its normal range. Okay? So that's mainly seen, again, in newborn babies, but if it's seen in adults, it's really counted as severe stress. So it's kind of interesting to see how you can see these things, and all of it is related to physics. Another really good one that is not mentioned in the textbook, but I felt like it was a really good idea to add it in here, is something called an electromyogram. So you're basically using an electromyogram to measure the muscle contractions or any of the muscle activities in your body. So it's called an EMG, electromyogram. So this electromyogram, basically, the main thing to know about it is that Motor neurons transmit electric signals that cause the muscles to contract. Okay? And again, electrodes are used as well, just like in the other tests and procedures used. And these EMGs, electromyograms, can basically detect a variety of things, including nerve dysfunctions and things like that. So it's really awesome to see how much physics is actually involved in these types of things, especially in the medical field. So I just feel like it's very important to know exactly why the human body is actually a very good ideal conductor of electricity. Another thing that's extremely important is knowing exactly what an ideal conductor is. An ideal conductor is an equipotential surface. Every point on or within an ideal conductor is the same potential. Okay, and again, the electric potential is just symbolized as an equation, and that's basically the best way of looking at it. The electric potential energy, the change in the electric potential energy, is defined as delta U is equal to negative W, or the work that's done. And a lot of the times that's why we see the muscle contraction, the beating of the heart, or even the heart contractions and the heart muscles contracting, is work being done on your body. And that is why electric potential is related to the human body, and why us as humans basically do conduct a lot of electricity. And so I hope that you can better understand just exactly how electric potential is related to the human body. Thank you. Another thing I would really like to add is the fact that in physics we know that two negative charges basically repel each other, and a positive and a negative charge, two different charges, attract each other. And in case you were wondering just how the ECGs or the EKGs or the electromyograms work, and how they measure this electricity that's created in the body, because our bodies are really good ideal conductors of electricity, is with the attraction of the positive and the negative charges in our bodies. So, in other words, the positive and negative charges come together because they are attracted to each other. And this is basically how the electricity flows throughout our bodies. So whether it be in the brain, our hearts, or our muscles, things like that, that's basically how it's done. A positive and negative charge attracting each other.